Hi, welcome to What's a 100-Year Flood? Part 2, Complications. In a companion video, What's a 100-Year Flood? Part 1, Basic Definition, we gave the basic idea of a 100-year flood. However, this model was pretty simplistic. Here we'll talk about some complications to that idea. So, the first complication that we'll talk about is that there's some imprecision in the use of the phrase 100-year flood in describing flooding events. Next, estimates of the probability per unit time that there will be a flood above some specified size have error bars. Also, we could ask if 100-year floods really are Poisson-distributed. And lastly, in the US, a hypothetical 100-year flood is used to define flood zones that are used for things like regulating where developments can be located and how much flood insurance costs. But these flood zones likely don't mean what you think they mean. Let's take a look at each of these issues. We're not going to resolve them, but just point them out. Okay, so first let's look at one bit of imprecision that sneaks into our language of 100-year floods. There are two subtly different common meanings of the term 100-year flood, and either of them might be relevant depending upon the situation. Okay, so first, there is the term as it is used in everyday language to describe real flooding events. This is the meaning we used in Part 1. Second, there is the definition used to define the 100-year floodplains used in the US for things like determining the price of flood insurance. First, we'll talk about the everyday definition, and then we'll get to the definition used for defining floodplains afterwards. Okay, let's start with what we typically mean when we talk about a 100-year flood. Let's say we have a river. Let's look at what various floods look like on this river. Here, we'll characterize the size of a flood in terms of water depth at a certain point on the river. In reality, it would probably be quantified by a river flow rate, but depth is easier to think about. So let's say that the average depth of the river at this point is 10 feet, but it varies due to how much rainfall has occurred in the recent past. Larger floods will occur more rarely than smaller floods, so the water level will reach 12 feet more often than it reaches 15 feet, and will reach 15 feet more often than it reaches 18 feet. So the average depth is 10 feet. Let's say that on average, once every 10 years, the depth of the water meets or exceeds 15 feet 3 inches. Now, to be clear, 15 feet 3 inches is the depth that is met or exceeded once every 10 years on average. So this means it meets or exceeds a depth of 15 feet 2.9 inches slightly more often than once every 10 years, and it meets or exceeds a depth of 15 feet 3.1 inches slightly less often than once every 10 years. This defines a water depth of 15 feet 3 inches as the 10-year flood depth. Every time the water depth goes above 15 feet 3 inches, that is a 10-year flood. Similarly, say the water depth meets or exceeds 17 feet 7 inches on average once every 50 years. This defines the 50-year flood depth. If the depth goes above 17 feet 7 inches, that is a 50-year flood. Let's also say on average the depth of the water meets or exceeds 19 feet once every 100 years. And on average, the depth meets or exceeds 20 feet 9 inches once every 500 years. So anytime the water depth goes above 19 feet, that is a 100-year flood. And anytime it goes above 20 feet 9 inches, that is a 500-year flood. It's important to note that 500-year floods are a subset of 100-year floods. Any flood that exceeds 20 feet 9 inches also exceeds 19 feet. Similarly, 100-year floods are a subset of 50-year floods, which are in turn a subset of 10-year floods. In particular, as 100-year floods occur half as often as 50-year floods, half of all 50-year floods are 100-year floods. Similarly, 1 in 5 10-year floods is a 50-year flood, and so on. So, in our river example, a 100-year flood is a flood that exceeds the 100-year depth of 19 feet. These happen on average once every 100 years, and we took them to be Poisson-distributed in Part 1. Note that by this definition, not all 100-year floods are of the same size. For example, let's say a flood occurs, and a flood that big or bigger only happens on average once every 140 years. If someone describes this flood, they're probably not going to call it a 140-year flood. They're more likely to just call it a 100-year flood. So if a flood is described as a 100-year flood, that statement likely isn't as precise as it initially sounds. Okay, now let's get to the second definition of 100-year flood that is in common usage. This is a hypothetical 100-year flood used officially to determine the location of floodplains, at least in the US. It is often referred to as the 100-year flood, but is also called the base flood. For clarity in the rest of this video, if we mean the hypothetical 100-year base flood, we'll refer to it as the 100-year base flood. If we mean the previously described 100-year flood, we'll just call it a 100-year flood. Okay, so let's define the 100-year base flood. The 100-year base flood at a given location is the hypothetical flood of a size such that a flood that large or larger at that location is expected only once every 100 years. This defines the 100-year base flood to have a very specific size. Now, in our example, a 100-year flood was a flood with a depth of at least 19 feet. The 100-year base flood, however, has a depth of exactly 19 feet. As a side note, here's another way of looking at the 100-year base flood. When we defined 10-year, 50-year, 100-year, and 500-year floods, conceivably we could have also made a finer gradation. Let's imagine that we defined 101-year floods, 102-year floods, etc. The 100-year base flood is a hypothetical flood that is a 100-year flood, but is not a 101-year flood. So, the 100-year base flood is a theoretical flood, but with a concrete definition. Note that it is not expected that the 100-year base flood will occur once every 100 years, even on average. What is expected is that a flood as large as or larger than the 100-year base flood will occur every 100 years, on average. So, when describing a real flooding event, if people call it a 100-year flood, they really mean a flood as big or bigger than the 100-year base flood. Unless, of course, the flood is so large it qualifies for another term like 500-year flood. Okay, so now let's move on to the next issue. Error bars on the definition of the 100-year base flood. Determining what constitutes the 100-year base flood requires complicated measurements and analysis, and the data used to make such a determination may be lacking. The size of the 100-year base flood is only going to be determined up to some uncertainty. In our example, instead of being able to definitively say that the 100-year base flood has a depth of 19 feet, we may instead only be able to say that the 100-year base flood has a depth of 19 feet plus or minus 8 inches. So this size will have an error bar, and that error bar typically goes unsaid. Okay, next, let's look at a basic assumption of a Poisson-distributed process. We assume that the probability of the event occurring is constant in time. And this may be a poor assumption. Changes in local climate, river conditions, or development of an area can make floods of a certain size more or less likely. Thus, the definition of the 100-year base flood can change with time. So, calculations used to compute the characteristics of the 100-year base flood may be valid for much less than 100 years. You may live in a place which is not expected to be affected by a flood like the 100-year base flood, but conditions could change and you could unexpectedly find yourself in a 100-year flood zone. Okay. We can also question whether or not 100-year floods really are independent events. So this was assumed when we took them as Poisson-distributed. But perhaps certain weather conditions make multiple 100-year floods in a short time span more likely. Or perhaps a 100-year flood can change conditions around a body of water to make another 100-year flood more or less likely. Okay. And lastly, let's talk about 100-year floodplains. In the U.S., these are used for determining how land can be used for building and for determining the cost of flood insurance. A 100-year floodplain is the area expected to be flooded in a flood identical to the 100-year base flood. It might therefore be easy to conclude that a spot inside the 100-year floodplain would be expected to flood, on average, once every 100 years. However, such a conclusion is too optimistic. This is because the outermost limits of the 100-year floodplain are the areas which would be expected to flood every 100 years. Areas well inside the floodplain would be expected to flood more often. Okay, so let's draw this out in pictures. Here, we'll ignore the issues previously mentioned about error bars on the definition of the 100-year base flood, whether or not the rates of 100-year floods are constant, and whether or not 100-year floods are independent. We'll pretend that the location of the 100-year floodplain is known exactly to illustrate this last issue. Okay, so let's say we have a river. Around this river is a 100-year floodplain. This is the region expected to be flooded in the event of a flood identical to the 100-year base flood. The edges of the 100-year base flood would just reach this contour. So, on average, one flood every 100 years would be large enough to touch or exceed this contour. If we similarly defined a 105-year base flood, it would just reach a contour a bit outside the 100-year base flood contour. So on average, it is expected that one flood will reach or exceed this outer contour every 105 years. So, for example, in 10,500 years, on average, 105 floods would reach the 100-year flood contour, and of those, 100 would also reach the 105-year contour, and 5 of them would not. And if we instead defined a 95-year base flood, it would just reach a contour a bit inside the 100-year base flood contour. But more importantly, as you go inward, you get to areas that flood more often, like the 50-year floodplain. A flood is expected to reach or exceed this contour every 50 years. So instead of thinking of the 100-year floodplain as the area expected to flood on average once every 100 years, we should think of it as the area expected to flood on average at least once every 100 years. Some parts of the 100-year floodplain will be much more flood-prone than expecting one flood every 100 years. Okay, so in this video we've tried to look at some subtleties in the definition of 100-year floods. The precise definitions of 100-year floods and 100-year floodplains, parameter uncertainties, and whether or not 100-year floods are really Poissonian complicate matters compared to the simple picture in Part 1. These are things which should be kept in mind when trying to understand statements about the 100-year base flood or real-life flooding events.